Good afternoon, Algebra 2 Trig Honor student. So this one is for Chapter 4 lecture. So again, I just want to divide into two-part, first half, second half. So the first half, we just want to go over some of the critical problem from 1 through 15. So for Chapter 4, it's all about polynomial, graphing, analyzing the maximum, minimums, the term, and finding the zeros. The most important thing, finding the zero. And also we'll talk about long division, synthetic division, and the P over Q, the algebraic fundamental theorem of algebra, the way to find out the number of zeros, the real zero, the complex zero, and so on. Okay, so now, and let's look at the first set of the problem here. So using graphing calculator, state a maximum number of terms of the graph of each functions could make, and then sketch the graph. State the number of real zeros, approximate each zero to the nearest tenth, and also approximate the relative minima and the relative maxima to the nearest tenth. So again, minima, that's just the plural of minimum, and maxima, that means the plural for maximum. So one thing that we need to figure out here is the graph. So far you don't have the technique how to make the graph manually. So we're using a graphing calculator or maybe using decimal. So the one that I do recommend you guys to purchase for the graphing calculator would be considered TI-83. Okay, let me just write it up here. So the latest model, well, TI-83, that's what we've been using for the past decade. So this one, I mean, it still works. 83 plus, or the TI-84, or the 84 plus. Or you can use that, the latest model would be the TI-84CE model. Okay, so those are the one I do recommend you to purchase. What about the Inspire? You can get one like that too, but that one it's a little bit complicated to use. So the Inspire, that one's a little bit more expensive. So the calculator feature, I'm going to show you how to use that in trig and also pre-calculus and calculus. But so far for Algebra 2 Honors, we'll just stick with the decimal first, because that's easier to find out all those elements, the turning points, all that, maximum, minimum, the zeros. So now let's do the even number. Let's start it off with number 2 here. So number 2, we do have f of x equals x to the power of 4 plus x to the power of 3 minus 3x squared plus 5. And you probably want to say that the name for this polynomial. So this one involved with 1, 2, 3, 4 terms. So this one is considered the 4-degree quadranomial. Okay, so it's a 4-degree quadranomial. So make sure that you know the prefixes. 1, that's considered mono, one term. And then 2, that would be considered binomial. And then 3, that means it's considered trinomial. And then 4, quadnomial. So on and so forth. Okay, so now let's put it into the decimal here. So decimal, you don't need to sign up for any account, but the things that if you want to download the app, you can always download it on your phone. The good thing about decimal, you guys probably know how to use that. Some people probably don't know how to use it. That's fine. So I'll show you that. For the state tests, so let's say that once you're taking the SBAC, so there's certain kind of problem. You know, they probably do have the decimal feature. You can use that as a calculator. But by the time you're taking the college placement test, or you're taking the AP calculus test, or the SAT, things like that, and they all require using the graphing calculator, and there's no decimal allowed for that. And also, even by the time you go to college, there's no decimal for the math classes or any science classes. Okay, because that requires using a phone or a tablet. You know, things like that. So now let's just click that. So calculator. So what we got here, so we got y equals, so the 4-degree quadranomial. Excuse me, let me just go back to that one. So we do have x to the power of 4 plus x cubed minus 3x squared plus 5. So this one's a graphing calculator. We're not using that yet. So just decimal. So x to the power of 4, so you type in x. And then the power sign, the little caret. So that would be shift 6, caret. and then you want to type in that power 6. If you don't like to use this kind of feature, you can always click that the keyboard here, so you can use that the power sign. Here's the power sign. And now, before you type in the rest of the term, you need to bring down the cursor, so you press the right arrow. Okay, and then after that, plus x to the power of 3. Well, it's not x to the power of 6, it's x to the power of 4. Okay, so fix that, and then the right arrow, and then plus x to the power of 3. Again, press that caret for the power sign, and then type in 3. And now let's see what else that we have for those rest of the term here. So plus x to the power of 3 minus 3x squared plus 5. So minus 3x squared plus 5. Again, bring down the cursor. So now, here's the graph. So the things that you can always drag the graphs, you can just move it down, you can move it up, you can slide it over, things like that. Okay, so now, as you can see that the graph is going this way, decreasing, increasing, decreasing, and then increasing. So for the decreasing interval, we do have that from negative infinity to the position right here. Okay, let's find out those zeros. So it looks like we do have 2 real zeros. So the real zero we have is negative 1.818. The 0, that means the x-intercept, by the way. It's called the x-intercept. But for Algebra 2, it's called the zeros. And then this one, negative 1.474. And now for the minimum, so for the minima, we do have negative 1.656, comma, negative 0.248. And here's another relative minimum. So 0.906 for the x value, and the y value, 3.955. And then for the relative maximum, we do have 0, 5. So those are the number we can basically find it out from the graph here after you just put in the function. And now the calculator is showing that decreasing, increasing, decreasing, increasing. So according to the instructions, let's go back to the instruction here. So state the maximum number of turns the graph of each functions. So the number of turns, as you can see that. So this one is decreasing and then increasing to this position here. So that's considered 1 turn. And then all the way down here, this one is considered facing downward. It's an upside down parabola. You try to cut it out. So 1 turn, 2 turns, and then all of a sudden it's going to be facing up again. So facing up, facing down, facing up. So we do have 3 different turns of the graph. So the number of turns for the graph, we do have 3. And now let's see what else that we need to state for this one. Okay, so sketch the graph, we just did that. Make sure that you need to trace that through the template here. And then state the number of real zeros. So count the number of zeros. So we do have 2 real zeros. Okay, so 2 real zeros. And now for those you might be wondering, could that be the imaginary zeros? We'll talk about that later. Okay, so now let's go back to the instructions. So we do have 2 real zeros. Approximate each zero to the nearest tenth. So nearest tenth, that means 1 decimal place. So the first zeros, so once again, click that. So it's negative 1.8. And then another 0, so that's about negative 1.5. Again, you want to approximate it to the nearest 10. So that means you want to round it. And now let's see what else that we need to define here. Okay, going back to the instruction. So after we approximate the value of the zeros, so now we need to approximate the relative minima, relative maxima. So that's what I stated earlier. So for the relative minima, so we do have negative 1.656, comma, negative 0.248, the lowest point here. And here's another one. So this one is considered another minimum, relative minima, and 0.906, 3.955. And there's only one relative maximum, and that is 0, 5. Okay? So it's pretty easy to find out with the calculator, with the decimal. And then the way to do it on the graphing calculator, I'll show you that if we do have extra time for Algebra 2, or probably we'll get into that in Trig. Okay? So now let's see what else that we have for the rest of the template here. So the other two problems, pretty much you want to follow through the same guideline. So enter the functions, find out the rest of the zeros, maximum, minimum, the terms, stuff like that. And now, this one is brand new stuff, and behavior. Okay, so for and behavior. So before we get into the graph here, so let's talk about the and behavior. So let's say we have a random polynomial function with the graph. So let's say like going this way. So this one is actually going down all the way through. So let's say we have a function like this with a graph. So let's say this one is f of x. So and behavior, that means you want to find out the boundary of the graph as x approaches infinity and then x approaches negative infinity. And as you can see that if x goes to infinity, so let's say that x is getting bigger and bigger, so that means y goes to infinity. So here's how you state one of the boundary. So that's called the and behavior. And here's another boundary. So what about x goes to negative infinity? If x is getting smaller and smaller, it's getting close to negative infinity. So that means y goes all the way down to negative infinity. So basically by using the graph, you can just see that the boundary. Now what about without the graph? So the way to do it without the graph, we need to look at the power, the term with the highest power. So and behavior, another meaning for that is looking at the highest power term. Okay, so the highest degree term. So regardless what happened with the rest of the term, you always want to pull out the one with the highest degree term. So we do have f of x. So let's say this one is about f of x equals x to the power 4. And now you want to do the analysis. So x goes to infinity. So what happened with the y value? So that means y is getting close to infinity to the power of 4. So what I did here, instead of looking at the whole function here, I'm just focusing on the highest degree term. So infinity to the power of 4, guess what? It's just another big number. Another big number, so let's say that it's another infinity. Again, infinity, that means can be 1,000, 10,000, 100,000, 1 million, a trillion, a billion, things like that. So now, what about for the other directions? So what happened? X is getting smaller and smaller to negative infinity. So that means y is getting close to negative infinity, quantity to the power of 4. So negative infinity to the power of 4, guess what? It's negative infinity times negative infinity times negative infinity times negative infinity. So that means you multiply negative infinity 4 consecutive times. So eventually it's going to be a positive infinity, a very big number. So this one, basically that shows the and behavior. Again, it shows the directions of the graph. It shows how the y value behave, whether that's going all the way to infinity or goes all the way down to negative infinity. Okay, so for the other one, you want to do the same thing. But you got to be careful with the negative sign, the sign change. Okay, so now, what about for finding the product? So finding the product, it's basically just distribute. So basically that we want to regroup them, and then we just want to distribute. So trinomial multiplied by the trinomial. So this one can be written as 7b squared times this trinomial, negative 2b squared plus 6b plus 5. So first thing that I want to do, you want to regroup them. And then after that, it's negative 3b times the same group, negative 2b squared, the same trinomial, plus 6b plus 5. And then the constant term, minus 4 times negative 2b squared plus 6b plus 5. And then the rest of this, you want to distribute. Again, this one you don't want to do it mentally. You don't want to rush through it. So you want to show all the process, all the work. So 7 times negative 2, that's negative 14. B squared times b squared, b to the power of 4. Again, same degree. multiplying the power, you want to combine them. And then the next term, similar. So 7 times 6, 42. So b to the power of 3. And then the third term, 35b squared. And then this one here, negative, negative, positive. So 6b to the power of 3. And then negative 3b times 6b. Then that'll be negative 18b squared. And then negative 3b times 5 minus 15b. And then the rest of this, similar. So negative times negative, positive. So positive ab squared. Negative 4 times 6b, negative 24b. And then negative 4 times 5, negative 20. And now for the rest of this, you want to combine the like terms. So anything that's related with b to the power of 4, you want to combine them together. And since like there's only one term with that b to the power of 4, just leave it. So negative 14b to the power of 4. Again, the way to rewrite it, it's always from the greatest power to the least. And now the next one, so compare that to one with b to the power of 3. Underline them. So 42b to the power of 3 plus 6b to the power of 3. So 48b to the power of 3. And then 35b squared, negative 18b squared, ab squared. Combine all of them together. So 35 minus 18, then that would be considered 17b squared. And then plus ab squared, so it's 25b squared. B to the power, b to the power of 2. And then what about the one with b to the first power? So negative 15b, negative 24b, which is negative 39b. And then there's only one constant term, so the constant term, just carry that over, so minus 20. So now finally we do end up with 4 degree, 1, 2, 3, 4, 5, pentanomial. So it's a 4 degree pentanomial. Okay, so now for the rest of this, so we did the one with multiplication with the polynomial. What about the one with quotient, division? So for division, we do have two different ways to do it. So you guys do remember things that you learned from Algebra 1, the long division. And then for Algebra 2, there's another technique. It's a brand new technique. It's called the synthetic division. So I'm going to show you both, okay? So I'm going to show you both the way to do the long division and the synthetic division. But for the synthetic division, there's a requirement for that. We'll talk about that in a minute. So let's start with the long division, something that you learned from Algebra 1 already. So now let me just copy and paste this one so I can show you that on the brand new page because I need more space for this. Okay, so let me just click this one, copy and paste if that's possible. Okay, let's see. Yeah, otherwise I need to rewrite it. So it's kind of weird, so let me do it this way. Yeah, it seems like it doesn't allow me to copy and paste this one here. Okay, so I just want to do it here on the active inspire. The 9 is not part of it, so I'll just delete that. Okay, so now let me just rewrite this one. So this one is considered 3n to the power of 3 plus 2n squared. So this one doesn't recognize the exponent. Minus 6n plus 8. And now you want to divide this quadnomial, the cubic quadnomial, by n plus 2. As you can see that this one is called a dividend. And the linear binomial, this one's called a divisor. So for the long division is always the format with the dividend divided by the divisor. So dividend goes inside. So 3n to the power of 3 plus 2n squared minus 6n plus 8. And then divisor, we do have n plus 2. So now, in order to find out the quotient, so we need to compare that to terms. So the divisor is a binomial, so we need to start it with the binomial. So in order to cancel out that 3n to the power of 3, so what I need to multiply, it's considered 3n squared. Because 3n squared times n, so that would give you 3n to the power of 3. And then 3n squared times 2, so that would give you 6n squared. instead of combine them, so you want to subtract because you want to get a remainder. So once you get a remainder, so you see that the first pair of terms got canceled. So this one got canceled. So we do have 2n squared minus 6n squared. Then that would be considered negative 4n squared. And now you want to bring down negative 6n. Again, binomial versus binomial. So in order to cancel out that negative 4n squared, so what I need to multiply, it's negative 4n. So negative 4n times n, negative 4n squared. Negative 4n times 2, so negative an. Subtract, so this one got canceled. So negative 6n minus negative an. So it's like negative 6n plus an. So then that'll be 2n plus 8. So finally, so let's figure out the number to cancel out that 2n. So we need to multiply by 2, because 2 times n, then that'll be 2n. 2 times 2, that's 4. And for those students might be wondering, this one is not divisible. Well, the things that no need to worry about it, so we just end up with a constant remainder. So a minus 4, then that'd be 4. And now the way to rewrite it, so that would be considered a quotient plus the remainder over the divisor. If you guys just recall what you did in Algebra 1, so the quotient for this one, it's always the top part right here, which is what? 3n squared minus 4n plus 2. It's a trinomial, quadratic trinomial. And then the remainder, which is what? It's a constant 4 over divisor, n plus 2. Okay? So long division, so that's the first method. You can always use the long division to divide by any kind of polynomial. But make sure that the polynomial, the degree in the dividend, it's always greater than the degree in the divisor. If that's the other way around, you cannot divide it, because that would be like a fraction. So again, the degree on the top in the dividend must be greater than the degree in the denominator of the divisor. So first method, it's about using the long division. Okay, let me just... Okay, so now what about the other approach for this? Well, the other approach for this one is called a synthetic division. So you guys probably will enjoy this one better because there's no need to worry about the variable. Now, synthetic division, when can we use the synthetic division? So for the dividend, so dividend can be any kind of polynomial. So this one can be any polynomial. But there's a requirement for the divisor. The divisor, the requirement for that, it must, okay, so make sure that you need to satisfy the requirement. So make sure that the divisor is going to be considered linear binomial. Well, what I mean by linear binomial is that it's showing it's like x plus a or x minus a. See the structure for the divisor? So the highest power is always 1. So that's why it's called linear. Binomial, that means 2 terms. Okay, so using the same example, let's use that the synthetic division for this. Okay, so let me just go back, copy and paste. Same problem that we're doing. So again, for that number 8, so we do have dividend, which is 3n to the power of 3 plus 2n squared minus 6n. I'm just rewriting it. So this one is the dividend. And then divisor, we do have n plus 2. Now, the things that for the synthetic division, instead of dealing with the variable, guess what? We just want to take out the coefficient for this. So dividend, we do have 3, always from the greatest power to the least. If you see like a missing term, you want to put in 0. So we got 3, 2, negative 6, and 8. Guys, see the power here is getting smaller by 1 degree each time. What about the degree here? The degree here is like 0. And now, what about the divisor? In order to find out the divisor, you want to set that n plus 2 equals 0. Or you just take the negative number of that constant. So that means n is what? Negative 2. So this one's the divisor. And now, the way to perform the synthetic division. The first leading coefficient, you always want to bring it down. We don't do anything about it. So 3 times negative 2, so we got negative 6. And then instead of subtracting the number to get the remainder, we just want to combine them. So 2 plus negative 6, negative 4. And now you want to go through the same process again. So negative 4 times negative 2, so we do have 8. And then plus negative 6, we do have 2. So 2 times negative 2, again, going through the same process. So negative 4. So 8 plus negative 4, so we do have 4. And what do you guys notice? Anytime that you divide it, so that means the degree of the quotient is always considered 1 degree less compared to the original dividend. The reason why that is because the n behavior. The n behavior for the dividend, it's 3n to the power of 3. Once you divide it for the divisor, so that's n. So that's why we end up with 3n squared. So it's all about the n behavior comparison, dividend, divisor. So for the quotient, so that means we started with 3n squared. And then the rest of this, we just want to keep going down by 1 degree less. So 4n, and then plus 2. Now what about the final constant here? Guess what that is? That's the remainder. Whatever the final constant that you have for the synthetic division, it's always considered the remainder. So it's 4 over n plus 2. So compare the previous one that we just did. Is that the exact same thing? So 3n squared minus 4n plus 2, and then plus 4 over n plus 2. Okay? So now, let's see what else that we have besides the synthetic divisions, the long divisions. Okay, so now the rest of this type of problem here. So let's do another one. So let's say that, let's do number 10. Number 10, that looks kind of difficult. Okay, so let's see. Again, I just want to copy and paste this one so I can transfer that to the active inspire. There you go. Okay, so let's open up the new slide. So what we got here, so we got 6n to the power of 4. Again, just want to rewrite it first. Minus 24n to the power of 3. And then minus 66n squared, it's a big number, plus 12n, and then plus 52, divided by the quantity of 6n plus 6. Now, compared to the previous one, if you guys can tell me about the difference here. Well, dividend, so this one is just considered 1, 2, 3, 4, 5. It's a 4-degree pentanomial. Divisor is you consider a linear binomial, but the problem is that there's a 6 right in front of that variable. So for the dividend, so we just bring down the coefficient. We got 6, negative 24, negative 66, and then 12, and then 52. Now, what about for the divisor? How do we take care of the divisor? So the divisor, this one, we can always factor out that 6. So we do have n plus 1. Another way you can find out the divisor, you can always do this. So set that the denominator or the divisor equals 0, and then you solve for n. So that means n is negative 1. Now you got to be careful with this. Divisor for the synthetic division is negative 1. But once we rewrite it, there are certain things that you need to do. And I'm going to show you that in a minute. So now let's just perform the synthetic division. So first number, bring it down. So 6 times negative 1, negative 6. Negative 24 plus negative 6, negative 30. So negative 30 times negative 1, so that's positive 30. Plus negative 66, negative 36. And then negative 36 times negative 1, then that's positive 36. And then 12 plus 36, then that'll be considered 48. And then 48 times negative 1, negative 48. So that means the final remainder, which is what? 4. And now we come up with the quotient. So we do have 6. Again, the degree, starting degree, it's always 1 degree less compared to the divisor. I mean the dividend. Because that's the n behavior. So n to the power of 4 divided by n, then that would be what? just n to the power of 3. And then the rest of this, minus 30 n squared, minus 36n, and then plus 48, and then plus the constant, which is the remainder, over the original divisor, 6n plus 6. And now, gotta be careful with the quotient that you're dealing right here. So anytime that we take out that 6, you see that the divisor, so let's say that the divisor is considered something over. Okay, so let me just put in the remainder back. So this one, it's considered 4 over 6 times n plus 1. And as you may notice, you see that 6 right here? Guess what that is? It's the greatest common factor. So try to separate it out. This one is considered 1 over 6 times 4 over n plus 1. So whatever the greatest common factor that you pull out, guess what we have to do with the quotient eventually? We need to multiply that quotient by the greatest common factor. So eventually, so the real quotient, that would be considered n to the power of 3 minus 5n squared minus 6n, and then plus 8. And then plus the original remainder over the original divisor. And that would be considered the final solution. Okay? So anytime that I see the number right in front of that variable in the divisor, if something that it's other than 1, make sure that you always want to pull out that number, and you always multiply the reciprocal of that number. Okay? So now, let's move on to the next type of problem and see what else that we have for the rest of this on this first half of the lecture. So for number 12 to 15, so this one you want to state the number of complex roots. Again, there's another meaning for the roots. So for algebra 1, so x-intercept, that's something you learn, x-intercept. And then algebra 2, we talk about the zeros. And then the roots. Guess what? They pretty much mean the exact same thing. So anytime I see like zeros or roots, that means we're looking for the x-intercepts. So state the complex root, the possible number of real and imaginary roots, and the possible rational roots for each equation. And then find all those roots. So anytime that we do have a polynomial, so let's say we do have something like p of x. So in general, so a x to the power of n plus bx to the n minus 1, and then plus so on and so forth. You see that the power is always 1 degree less. Again, this one is just like a general pattern. Plus, eventually, let's say that it's qx, and then plus a constant c. So whatever the highest power that you have, so this one would tell you the number of complex 0, the possible complex 0. Or you can say that the number of solution you have for the x-intercept. So the value of n, so this one is saying that's the number of possible, the number of zeros. While the 0 could be considered either rational, irrational, and also could be considered imaginary. So what the instruction is saying that, instead of saying that complex, I don't like the word complex, so I just want to say that it's just the number of zeros. So this one, just fix that, the complex root. So what the instruction is asking for is actually the possible zeros. Okay, so again, it's always determined by the number of n, the number of n. So like number 12 right here, so the highest power is 3. So that means, so for the number of total zeros, we do have 3. So 3 zeros. Again, we don't know what those 3 zeros are. It could be either the rational number, irrational, or complex number. Okay, so we'll find out. And now another thing that you need to find out here is the possible of real and the imaginary root. So now this one got to be careful to deal with. If that's like a possible real roots, so the real zeros we have, it could be considered either 3, or it could be less than that number, by an even number. So less than by an even number, so that means 3 minus 2. It could be 1 real zeros. It could be either all 3 real zeros or 1 real zero. Okay? Now, what about for the complex, for the imaginary root? For the imaginary root, then that would be the even number. So if the real zero, they consider odd number, so that means the imaginary, then that would be the even. So that means the imaginary root, then that would be considered 2 or nothing. Again, it's always less than the number, the total number, by another even number. So 3 minus 2, so we'll get 1 for the real zero. And then imaginary, it's always the other type of number, the even number, so 2 or 2 minus 0. And now, what about the possible rational roots? So the possible rational root here. So here's one thing that I would like to introduce. In order to find out the possible rational root, so we need to apply that, the algebraic theorem, P over Q. So again, if you see that the structure here, so P, so this one, it's the number, well, let's say, so P would be the constant number. Or we can say that it's the possible factors of the constant term. See that, the general equation for the polynomial? So for the value of P, it's the possible factor of the constant term. And guess what? For the value of Q, this one is the possible factors of the leading coefficients of the polynomial. Okay, so here, so for A, we do have 1. And then for C, we do have negative 64. So this one, compare that, negative 64 over 1. And then we need to list all the possible factors for this. So we do have plus minus 1, plus minus 2, and then plus minus, well, just keep going, any possible factor of 64. Perhaps plus minus 4, plus minus 8. Hopefully there's nothing missing here. So plus minus, what else? Plus minus 12, if that's possible. Okay, let's see. No, not 12. And plus minus 16. Okay, so and then so 4, plus minus 32. And then plus minus 64. All over, plus minus 1. So once you divide it, so that means the possible rational roots, then that will be considered plus minus 1. Okay, so the possible rational roots. So we do have plus minus 1, plus minus 2. It's pretty much the same thing again without that over plus minus 1. Okay, so it's all this. So now, let's find out all those actual roots, okay? So we need to find out the real and the rational, the rational, the irrational, or the complex. So the way to do it, we can either factor it, if that's possible to factor. If that's non-factorable, that means we need to verify all those possible roots by using the synthetic division. So it looks like this one is factorable, so I'm going to open up the new slide here. So since we do know that one, it's factorable. So x cubed minus 64. So one thing that we notice in Algebra 2, we do have the difference of 2 cubed and the sum of 2 cubed formula. So the difference of 2 cubed, we do have a cubed minus b cubed. Once you expand it, it's like a minus b times a squared plus ab plus b squared. So this one is called the difference of 2 cubes. Again, if that's factorable, it's better for you to factor it first and then find the zeros. And then the other one is called the sum of 2 cubes. So it's quite similar to the first one. So it's a cubed plus b cubed. So once you expand it, so it's a plus b times the quantity of a squared minus ab plus b squared. So for this one, you try to break it apart. So we do have x, and then 64, we do have 4, 4, 4, and 4. So once you expand it, so a, that means what? X. And then b is 4. So using the pattern here, so we do have a minus b, so it's x minus 4, times the quantity a squared, so which is what? X squared, plus ab, so 4 times x, or x times 4, 4x. And then plus b squared, plus 16. And now you want to set it equal to 0. Well, there's no need to square that, the whole thing outside. I just put in the extra exponent. So let me just erase that. So now let's find out the zeros. So we do have x equals 4, so the rational zeros, so we do have 4. Now what about for the irrational? You see that the trinomial here, so it's non-factorable. If that's non-factorable, guess what we can do? We can use the quadratic formula for this. Again, back to the real zeros, we do have 3 real zeros. Okay, so this one, a is 1, so b is 4, and then c is what? 16. So negative b plus minus, so negative 4 plus minus, b squared, so 16, minus 4 times a times c, so 4 times 1 times 16. So we do have 1 real zero, so for the rest of this, it might be considered imaginary. So this one is called real root. But now let's find out the imaginary root. So we do have the quadratic formula. So let's solve for this and see what happens. So negative 4 plus minus. So 16 minus 64. So 16 minus 64, which is what? Negative 48 over 2. So we do have negative 4 plus minus. So we try to break it apart. This one is considered 4 root 3 I. Again, the square root of negative 1, we can just pull that out as I, imaginary number, over 2. And then once you divide it, so what we got here is negative 2 plus minus 2 root 3i. So what I did here, just divided by 2 top and the bottom. So we do have 1 real roots, and then we do have 2 complex roots. And then all the solution together, so the total number of 0, we do have 3 of them. 1 real and 2 complex roots. Again, total, it's what? 3 solution, 3 zeros. So now let's do another example like this. So I know this one might be a little bit kind of confused for some people. So now here's another one. So again, always take out the one with the highest power. So the highest power, which is what? 5. So n is 5. So that means we do have 5 possible zeros. I don't want to say possible, 5 0, because some of those might be considered rational, some of those might be considered imaginary. Okay, so just say that 5 0. So according to the instruction, it's saying that define the complex root. So we do have 5 complex root. What they mean by the complex, it's a little bit different than a complex number. So I just want to say that it's 5 roots, okay? So 5 different roots. Okay, so now, another thing we want to define here, it's the real root and the imaginary root. So for the real one, it's always following by this number. So the real root, we do have either 5, again, or can be less than that number by another even number. So it's 5 minus 2, then that'll be 3. Keep going, 3 minus 2, 1. And then for the imaginary root, then that would be considered, or the imaginary 0. Again, root 0, that means the same kind of meaning. So it could be the even number, 4. Subtract by 2, so it's always less than that number by other even number. So 2, or no imaginary root, no solution, 0. And now let's see what else that we need to define. So define the possible rational roots. So that means we need to go by the process, p over q. So let's just circle the number. So p is what? 16. It's always the constant term. So we need to find out that the possible factors of 16. And then q is always the leading coefficient. We need to find out the possible factor of 1. So the top one, 16 right here, we do have plus minus 1, plus minus 2, plus minus 4, plus minus 8, plus minus 16. Denominator, we do have plus minus 1. Okay, so we find out all the possible rational roots. And then once you divide it, so that means just plus minus 1, plus minus 2, plus minus 4, plus minus 8, plus minus 16. So this one they call the possible rational root. So now we actually have to find out the roots, okay? Whether that they're real or imaginary number. Okay, so the way to do it. So this one, it's non-factorable. So what we have to do, we actually have to go through the process of synthetic division. As you can see that, so we got plus minus 1, plus minus 2, plus minus 4, plus minus 8, and plus minus 16. So we're going to verify all those number, or perhaps one of those number, and to find out one of those real root. So once we be able to verify it, so for the rest of this, so that means we can find out the rest of the roots by either factoring it or using the quadratic formula once we get down to quadratic. So you see that in a minute. So there's so many possibilities. So you're probably wondering which one we need to try first. So according to the list, so it's better for you to try the median number. The median, that means the number here in the middle. So I would say that you probably want to try that 4 or negative 4 first with the synthetic division. So the way to do it, so using the synthetic division, so started with the dividend, the original polynomial, so we do have 1, negative 2, 2, negative 4, negative 8, and then positive 16. And then let's say that the first attempt, the first trial, we're using x equals negative 4. So first number, bring it down. Again, synthetic division. So 1 times negative 4, so that would be negative 4 plus negative 2, negative 6. And then negative 6 times negative 4, positive 24, plus 2, then that would be 26. And it looks like the number is getting very big. Okay, so there's no way that the remainder is going to be 0. So for those you wondering which one's going to work, as long as the remainder is going to be 0, then that will be considered the real root. So it looks like negative 4 doesn't work. But what about, let's try positive 4. Okay, so let's try positive 4 and see what happens. Okay, so 1 times 4, that's 4. Again, we just want to get some small number first. If the number is getting bigger or extremely small, that means the remainder cannot be 0. So 2 plus 4, then that would be positive 2. And then 2 times 4, then that would be what? 8. So combine them, so then that would be 10. So 10 times 4, then that would be considered 40. And it looks like this one's getting pretty big too. So 36. So the median, that, well, both of them don't work. Okay, so now let's try some small number. Small number, what we got here, 1 and negative 1. Okay, so now let's try 1. So this one basically just like guess and check. You cannot just simply plug in a number and find out that the rational zeros. So that's why this kind of problem, it's a little bit tedious and it's a little bit tricky. So let's say x equals 1 first. So 1 times 1, so we do have 1, so negative 2 plus 1, negative 1, times 1, negative 1, 2 plus negative 1, then that would be 1. 1 times 1, 1 plus negative 4, negative 3, times 1, so negative 3. And then this one is negative 11. Again, it's not going to work. Negative 11 times 1, negative 11. So the remainder for this one is 5. Again, we need to end up with the remainder, which is what? 0. Another thing that I probably want to find out, so you can just, put it into the calculator, the graphing calculator, and see what the first real 0 is with the rational number that we find out here. So 1 doesn't work. What about negative 1? Okay, so let's try that. Again, this one, it can be taking a lot of time. So you've got to be careful with the number that you pick. Because it depends on whether that you're lucky or not. Some people that they're pretty lucky, they choose the first number and then they're going to find out the remainder is 0. So that would be the first rational root. Excuse me. So let's try -1 first. So 1 times -1, so -1, combine them, -3. -3 plus times -1, so that would be what, 3. Combine them, so it's 5. So we got -5 here. So 5, -5 times -5 plus -4, then that'll be -9 times -1, then that'll be 9. And then 9 plus -8. No, it's not going to work. So you probably want to try the even number. Another reason why you want to try the even number, if you guys take a look at that, the dividend, what happened with those numbers? The majority of those numbers they consider even. So we tried 4 and -4 previously, they don't work. Well, because that 4 is too high, compare that to a -2. But what about if we choose -2 or 2 first? Is that considered the greatest common factor? So let's try 2. So 1 times 2, then that would be considered 2, plus -2, 0. 0 times 2, 0, plus 2, so that's 2. 2 times 2, then that would be 4. 4 plus -4, 0. 0 times 2, 0, plus -8, -8. And what happened with this? So it's going to be -16 plus 16, which is 0. Bingo. It works. And now, so this one here, again, the power compared to the original dividend, it's always 1 degree less. So the way to rewrite it, so this one is considered n. Well, we're not using n for this. N is just the power. So we're using the variable. So it's 1x to the power of 4. Or x to the power of 4. And then plus 0x to the power of 3. Plus 2x squared. And then plus 0x minus 8. There's no more remainder, so there's no need to consider the remainder. But don't forget about the divisor, the one that we put in here, times x minus 2. And now what about for the rest of the polynomial here? What happens once you rewrite it? Can we factor it? Because that's just considered quadratic. Well, it's not kind of like quadratic, but it's to the 4th degree. As long as that's a trinomial with the even power, so we can always factor it. So this one, try to factor, so it's what, x squared, and then -8, we can use what, +4 and -2. So that means once you factor the whole thing, it's x squared plus 4, and then x squared minus 2, and don't forget about this one, x minus 2. So once we find the zeros here, so we got 1 already, so we got x equals 2. So what about this? So this one could be considered plus minus √2. If you try to solve for x here, again, x squared minus 2 equals 0, so x squared equals 2. Square root both sides, quadratic, so it's what? Plus minus √2. And now what about for this one? Looks like this one is going to be imaginary. So x squared equals -4, so you set that equal to 0. Square root both sides, so that means x equals plus minus 2i. So for this one here, we do have 3 rational zeros. No, 3 real 0, 1 rational, 2 irrational, and then 2 complex 0. Okay, so total solution, we do have 1, 2, 3, 4, 5. 5 solutions because the highest power is 5. So as you can see that once you go through the synthetic divisions, so that means the rest of this, we can either factor it. What happens if that's not factorable? That means we have to use the synthetic divisions with another possible rational root again. So for the rest of this, so for the second part of the lesson, you'll see that I'm going to show you more example, the way to find out the roots, whether that's rational, irrational, or imaginary number. Okay, so thank you for watching the video today. So you're more than welcome to watch that over and over again. Okay, so I'll see you next time. Take care.